Okay, today and tomorrow we'll be talking about the differences between theoretical and experimental probability. Okay, today we're going to be working exclusively with theoretical, but we've been doing that for the last couple days anyway. Okay, the probability that we have been doing is called theoretical. Okay, theoretical is what should happen. Okay, what should happen. Okay, or what's expected to happen, or what you think will happen. Okay, any of these words work here, but it's what should happen. Okay, so if I'm tossing the coin, like in our example here, if I'm tossing the coin, most people would think that it will land on heads half the time because it's 50-50. So the probability would be 1/2. That's what it should be. But in reality, in the real world, probability is not what it's always supposed to be. Okay, and we'll learn about the experimental side tomorrow. But today we're only talking about what it should be. Okay, so like I said in our example here, if I toss a coin, the probability of it landing on a heads should be 1/2. Because there's a tails and there's a heads, so the chances of them landing on each other is 50-50. Okay, so like I said, this is just more of what we've been doing. Okay, we're rolling a standard die again. Remember, it has the numbers 1 through 6. Okay, so all the questions here. What is the theoretical probability that the next roll is an odd number? Okay. So, how many odd numbers from 1 through 6? I like to list all my possible choices if it's, feasible. So I have 1, 2, 3, 4, 5, and 6. Okay. There are 3 odd numbers. Okay. Remember, you want what you want over the total. Okay, so there's 3 odd numbers over 6 total. Okay, you simplify and you get a probability of 1/2. Okay. If I ask, you have to change it to a decimal. This would be 0.5 or 50%. In this case, I'm not asking for you to change it. You could just keep it as a half, but if you feel more comfortable with seeing the decimal or the percent, that's also fine. Okay. Number 2, what is the probability of getting a 1 or a 4? Okay. So I want a 1 and a 4, or a 4. So that gives me 2 choices out of the total of 6 choices, which is 1/3, or 0.3 repeating, or 33.3 repeating percent. Okay, this is just more of what we've been doing. Okay, I'm going over it one more time so you see the word theoretical. Okay, what we've been doing so far is theoretical. Okay, number 3, what's the theoretical probability that the next roll is at least 2? Okay, at least 2 means the lowest number you want is 2, and you want everything higher than that. Okay, so let me erase this here and this. Okay, so like I said, at least means that number and higher. So at least 2, I want 2, 3, 4, 5, and 6. That gives me 5 numbers I want out of the total of 6. Okay. Decimal for that is 0.83 repeating, or 83.3%. Very simple. Okay, and lastly here is now we're asking for, what I think I would get out of 100 rolls. Okay, my first step here is I want to look at what the probability they want me to get is. So they want me to roll a 3. Okay? So I'll get a probability for rolling a 3. Let's do black actually. Okay, so how many 3s do I have? I only have 1 3. So the fraction would be 1 over 6. Okay, and then once I have that fraction, okay, it's saying out of 100 times, how many times do I think it's going to be a 3? So all I do is I take my fraction I just got and multiply it by 100, which is the number of rolls they want me to try. Okay, you can use your calculators for this to make it a little easier. And you will get 16.6 repeating. Okay, but you can't have 0.6 of a roll. So usually I round up to the nearest whole number. So I will say 17 rolls will be a 3. Okay, that's the only new thing we're doing today is this number 4 here. Okay. Like I said, your first step is you want to get your fraction. So this one they were saying, roll a 3. My fraction for rolling a 3 is 1 out of 6. And then they say I'm going to roll 100 times. So I take that fraction I just got and I multiply it by 100. Okay, if you have any questions, comment.